So imagine if you are lost and if I tell you to move 10 meters, is that enough? No, you need direction as well. So that's why we need vectors. So by the end of this video, you will be able to learn the basics of vectors. So without wasting any time, let's get into it. So in physics, the physical quantities are divided into two parts: scalars and vectors. Scalars are the quantities that has magnitude only. For example, if I ask my friend what's his mass, if the answer is 60 kilograms or 130 pounds, this mass has only magnitude, it doesn't have any direction. So, hence, mass is a scalar. If I ask my friend, what's your height? If the height is 170 centimeters, this is the magnitude only. That means length is also a scalar. So what are vectors? The quantities which have magnitude and direction both. For example, if I ask you to push this box, but you will ask me two questions. How much do you want me to push? And the second is in which direction. So you need two things to push this box. One, how much, that means the magnitude, and in which direction, that is the direction. So a quantity that requires these two information to be asked is called a vector quantity. So if I tell you apply 5 Newton force in each direction, that's the complete information about pushing this box, where and to which position and how much. So that means the quantity here is force. Force is a vector quantity, right? So let's learn the representation of vectors. Vectors are represented by arrow on top. If A is a vector, A would be defined as arrow on top of A. So I told you vector has magnitude and direction both. So that means it has magnitude and direction to it. So we have learned a vector is denoted by arrow on top of it. Magnitude is denoted by that vector with the absolute sign, and direction is denoted by a cap, an arrow on top of it. So this is the complete notation of vector, which has magnitude and direction both. Now, in our example, our force was a vector quantity. So how will I represent force? Arrow on top of it. This is how we will denote force. Now let's learn about some terminology related to vectors. So if I say this is my vector, so the arrow side of the vector is called head of the vector, and the side which doesn't have arrow is called tail of the vector. So vector has two components, two parts basically, head and tail. And the longer the arrow is, the length of, let's say this is A vector, this is B vector. So the longer the arrow is, the magnitude of that vector is more. So the length of arrow defines your magnitude of vector. So in this case, the magnitude of A is greater than magnitude of B, correct? So the length only tells you about the magnitude of the vector. So now let's learn some definitions about vectors. First, we just have learned magnitude. We have defined our vector as magnitude and direction. So how will you get magnitude from this formula? You will just divide the vector by its direction. You will get the magnitude of a vector. Second is unit vector, or the direction of the vector. So this is again the formula of vectors. So how I will calculate the direction? Vector divided by its magnitude, I will get the direction or the unit vector of the parent vector. What do I mean by this? If I say this is my A vector and the unit vector to this is a vector which has magnitude 1 and direction same as parent vector. That means unit vector is a vector which has magnitude 1. Let's say this is 1 magnitude and direction is same as the parent vector, which is A. This is my unit vector of A, which I can write as A cap, right? Third definition is equal vectors. Two vectors are said to be equal if they have same magnitude and direction both. For example, these are the two vectors, A vector and B vector. The length of these arrows are same and they are pointing in the same direction. Hence, I can say that these two vectors are equal. But what if this is my A vector now, this is my B vector now. Now the length of the two vectors are same, but their direction is opposite. Hence, A is not equal to B, but the magnitude of A is equal to the magnitude of B. So equal vectors are those which has equal magnitude and direction both. Fourth definition is of zero vector. Zero vector, as its name suggests, a vector which has magnitude equal to 0, and it's denoted by 0 and an arrow on top of it. And we will talk about zero vectors in the further lectures, why a zero vector exists, why just not 0, why we need zero vector. So this is it for this video. I'll see you guys in the next one.